Review sheet F. I'm differentiating, so using the correct notation, dy dx. I'm going to be differentiating sine, so if I use my cheat sheet, sine differentiates to cos. So I'll have cos here. Now this part, the 2x, that remains the same. But my value that's in front of the x comes to the front when I differentiate. So my answer is dy dx equals 2 cos 2x. I'm not going to do all the questions from this part. Next one we're going to look at is part D. So again, correct notation, dy dx. I'm going to ignore the minus 4 to start with, and I'm just going to look at cos. What does cos differentiate to? Cos differentiates to minus sine. So I'm going to have a minus sine. This part stays the same, 3x, and the number in front comes down to be multiplied. Now I've got minus 4 times 3, that's minus 12, times by this part, minus sine 3x. 2 minuses here, so when I multiply them together, I've got a positive 12 sine 3x. In 1f, dy dx, we're differentiating cos again, so cos goes to minus sine x, minus sine, this part remains the same, so sine pi over 2x, and the number that was in front of the x, so in this case the pi over 2 needs to move to the front. I've already got pi there, and I'm going to multiply that by pi over 2. So now multiplying this out, I've got a minus sign here. I'm going to move to the front. Pi times pi is pi squared, so minus pi squared over 2, sine pi 2 over x. Just make sure you bring your sign out to the front. In question 2, we're looking at e to the 2x. So dy dx, and you'll remember that e to the x differentiates to e to the x. This time we've got e to the 2x. The 2x remains the same. This part hasn't changed. I need to bring this 2 down to the front. So dy dx equals 2e to the 2x. In part C, dy dx again, we're going to do each part separately. So to start with, differentiate this part, so e to the x differentiates to e to the x, and a 3 remains there. Now we're going to differentiate 4x. 4x differentiates to 4. 2D also has 2 parts, so if we look at this part first, dy dx equals e to the pi x, and our pi here needs to come down to the front. Remember, pi is a number, so we've got pi in front. Now to differentiate the second part, 3 pi is a constant. It's just a number, so it's gone. So our final answer then, dy dx equals pi e to the pi x. Question 3 uses a combination of skills from question 1 and 2. I'm going to do 3b. Look out for the notation here. It's no longer y equals, so when we're differentiating, we've got dh dx. So sine differentiates to cos. And this part stays the same. So 4x plus 3. Remember, the number in front of the x, so in this case the 4, gets moved to the front. We've already got the 2 there, so we're going to have 2 times by 4. Our answer is 8 cos 4x plus 3. The only thing to watch out for is it's only this 4 that moves to the front. Question 3c, this time s, so ds dx. Going to differentiate each term in turn. So bring the 3 down to the front, gives us 12x squared. This 3 is going to stay there. If we differentiate cos, get minus sine. So minus sine, the 5x remains the same. This number needs to come down to the front. You can just squeeze in a times 5 in there. Then our last term here, e to the x differentiates to e to the 0.5x, and the 0.5 also needs moving down to the front, so we're going to have 4 times by 0.5. If I tidy that up, ds dx equals 12x squared. Now I've got this minus sign here, so I'm going to bring it to the front. Minus 3 times 5 is 15. 15 sine 5x plus 4 times by 0.5 is 2. 2e to the 0.5